Hello everyone, welcome back to the channel. So in our last video we have completed the topic of loops properly. For loop, while loop, do while loop, we have done all of them. Now as I told you, in our next lecture we will be doing lists. So here is that lecture. We will be learning what lists are. First we'll just go through all the theories for getting a rough idea about lists. Then we will just move on to the Word file where I have made all the like program practices and all like examples, and then we will go to uh, what we say online compiler and we'll try it all over there. Okay, so from theory to high performance, a structured journey through one of the Python's most powerful data structures covering theory, live coding, examples, and hands-on practice. Alright, this is it. Theoretical foundations, the mutable sequence. So, what are lists first? Let us see it. They are ordered and mutable. Lists preserve insertion order and allow in-place modification of any element at any time. You can just like this can be just edited and modified at the same time in place only. Okay, memory architecture, contiguous allocation with a 12.5% growth factor for efficient dynamic resizing, so its resizing can be done easily like that. Zero based indexing, first element is at index 0, distinguish its expression from indexing token. So its first element is indexed as 0. Indexing is started from 0 and not 1, just like we did in the negative indexing and all, like we did that in previous lectures. Okay, so that it is. Now next, essential list operations, creation and querying, use index, slicing, and membership operator into uh, inspect and navigate lists. See, we have done slicing in our previous lecture. First we have to just give the start and then step thing. Okay, and membership operator in, we have done two membership operator is and in. Okay, so that here we can use first thing that we can use is index function over here. Okay, and the second thing that can be used is slicing. We have done slicing properly, we have done multiple examples of slicing also. So that thing only we are going to use, and in operator, membership operator in can be used to inspect and navigate the lists. Okay, transformation, append, insert, and remove, modify list contents dynamically and in place. So these are the things that will be used. That index will be used in creation, querying. Transformation, in transformation these things are you append, insert, and remove are used. Okay, and in rearrangement, sort and reverse are used to reorder the elements directly. No new list will be created for reordering it. It is going to just do that in the same list only. It is going to do that like reorder or sort the same list only. Key distinctions, what do we say, sort modifies in place and returns none. Sort is going to modify in place and that is going to return none, like the output is going to be as none. Use sorted to return a new sorted list. We can use sorted thing, this function, to mention like a new sorted list. Okay, this is the next one, building your toolkit. Okay, so in this we can see list comprehension. dynamically in a single readable expression. So single readable expression will be used for constructing the list. Not a lot of things are used in it to make it complex. It is going to be really easy to write it, and as it is a single line readable expression. See, like examples given x star 2 for x in range 10. Okay. Nested lists model multi-dimensional data matrices, grids, and tabular structures using lists of lists. You can use all of these things. You can make all of these things like matrices can be made, grids, tabular structures, and all can all be made using lists. Alright, so next is classic algorithms. So implement the sieve of Aristotle's and linear search to reinforce algorithmic thinking. Okay, advanced manipulations. So deep copying. Use copy.deep copy to clone nested structures safely, avoiding shared reference traps. So for these copy.deep copy can be used for cloning nested structures safely, and all the avoiding shared reference traps, like all the traps that are there for in shared references, that can be all avoided. And you can use this copy or deep copy. You need to just remember all of these things, like in last one slides also we saw, like index, slicing, append, insert and remove, sort and reverse. All of these things are necessary for you to remember, as these are going to be used later on. Enumerate gives index value pairs. Zip pair elements across multiple lists cleanly. Okay. Split converts strings to list. Okay, so split is going to use for converting all the strings into list. Like you got a string and you want to convert it into the list, the type of lists. Okay, so it you can use the split thing over there. And join can be used for this reconstruct formatted string for from list elements. See here, dot is like first you will write the name of the variable, then you will write dot and split. Like these all functions are used like this, like whichever are having dot in them, like that. Efficiency and pattern in practice. So stacks. Use append and pop to treat a list as a last in first out stack. A pendant pop can be used for this, for a last in and first out stack. Okay, queues. Use collection.dq, like it is first is queue and then dq for efficient first in first out behavior. Plain lists are costly at the front. Okay, first you just have to read all of this to get a normal, like supervised idea about it. Okay, the rest we'll just go in depth and then we'll do all of this. Just I'm trying to give you a no like basic idea about lists. Middle insertion cost. Inserting at index 0 is O, and appending to the end of 0 1, the architectural standard. So testing your knowledge, predict the output. You have to predict the output. We have already done the slicing thing, so I think it is not a very difficult task for you all to find predict the output of lists, right? So what does this will return? Test underscore list. It is going. You know that -1 is written like it is given the end. It is going to just reverse it. Whatever it will be, it's going to reverse that. Debug the bottleneck. Why is list dot insert 0, x inside a loop? Performance anti-pattern. Explain the underlying cost. So you can just ask yourself all these questions after everything will be completed. Like all this whole lecture will be completed, you can ask yourself. Then you can get an idea that how much you got and how much you don't. Palindrome also, the string is palindrome if it is same, like even if you reverse it or not, this its spellings are the same. And so we did that in last lectures. And so in that, the palindrome function was used for that. Sorry. Interactive quiz, multiple choice will be asked by you. What does pop return versus remove? Pop and remove, like what will be the difference between both of them, like that. Okay. And syntax check, correct correct syntax for initializing a 2D list with 3 rows and 4 columns. Error hunt, find the issue in a malformed slice assignment, spot the off by one or type mismatch. Okay, so this is what it is going to include. The list toolbox. Task 1, custom index. Okay, and then custom index, implement value index list value, mimicking built-in behavior, handle value error. And unit converter transforms Celsius list to Fahrenheit using list comprehensions. Reverse strings generate reverse strings from a day of the week list. Okay. Complete all three tasks to demonstrate mastery of a list creation, transformation, and iteration. Each task builds on previous. Start with custom index function, then apply comprehensions to the temperature converter and finish by manipulating string lists. Okay, so this was the assignment for that for doing at the end. The power of lists. First of all, let's have a recap of what we did in this PPT. Recap is lists are Python's bedrock, ordered, mutable, and endlessly versatile for real world data. Alright. So strategic takeaway, prioritize append over insert 0, x. Okay. Choose the right tool to optimize execution speed. Next steps are transition to sets, dictionaries, and tuples as your data structure toolkit expands. Fine. So lists. Learning objective. By the end of this lecture, you all will be able to understand what a list is, create and manipulate lists. You can create the list and you can also like put some changes in it, like you can manipulate it basically. Assess, modify, add, and remove list elements. You can assess them, you can modify, you can add anything to it, you can remove anything from it, and in any of the list elements. You can do all of these, perform all of these, any of these functions. Use common list method. You can use common list method. What is it? You'll get to know later in this lecture only. Traverse list using loops. Apply list operation to solve real world problems. Basically, why do we learn anything? Why do we like learn anything in Python or anything in our life? Because we can just put it in some real life example. You can use that in your life. If we learn maths and all to use in our life, to apply it in our life, that's the basic thing why we are learning anything. So that is why we are learning uh, this list, because we can just use it in solving our real world problems. So part one is theory. Introduction to list. What is a list? A list is an order mutable means changeable collection of elements. Okay. A list can store numbers, strings, boolean values, mixed data types, even other list, nested list. Nested list, like a list inside a list will be nested list, just like conditional statement were nested and loops were nested. Similarly, list can also be nested. Okay, so it can contain anything like numbers, strings, boolean values, mixed data types can be used, like integers, anything can be used inside Examples here are like fruit. This all can be used. This is a list. Okay. Why do we use a list? Without list, we are writing something like with list. See, it is basically making our code very smaller and it is easier for us to write the data inside our code. You can only write student here and like this. You need not to write everything separately like this. Okay. Advantages. Store multiple values in one value. You can store lots of values in just one value, just like how we did in this students thing. We store lots of values in this one thing only. So you can basically save your time, save your space, and improve readability. That is it. You can store lots of multiple values in just one value. Easy to update. It is easy to update in this. Easy to search. You just have to search within the list. You want to find, wander around in the whole thing to find something. So it is easier to, uh, the easier to search also in list. Okay. And the next one is saves memory and code. It saves memory and code. Okay. Now further is creating list. Now we just read everything that what it is meant for, like what it is meant and all, like basic thing we did. Like what is the meaning of list and all, we did that. Now we learn how to create list. How, like that is the basic thing. But how you are going to create list? Otherwise, how could you know to do anything on list? First is empty list. What is empty list? This numbers. Then put a bracket. Then write nothing inside it. It becomes an empty list. Integer list. Integer list is going to have numbers inside it. Integers inside it. That makes it a integer list. String list. String list is going to have text values inside it. Okay. Mixed list can have anything inside it. Numbers, float values, boolean values in strings, anything. And then list indexing comes. Each element has an index. That thing we have done in indexing, just that is how you do the slicing thing. If you are, indexing only, then you can do slicing. Okay. So, I'll just suggest you to know. If you just forgot it, just go through the topic of indexing so that you know. Each element has an index. So this is the list written over here. Each of these elements are going to have some index. This is 0, 1, 2, 3. See. Here positive index. See, even if you forgot, you can look over here. Here it is given. This one is given 0, 1, 2, 3. But if you are starting from the last element, then you have to count from reverse, like -1, -2, -3, -4, like that. So it will become a negative indexing. So this is how indexing works. If you want to print the index, like the element that is written on the index value of 0, then you just have to write print, then the name of the variable, name of the list basically. Now it will be the name of the list here. Then inside the box bracket, you have to write on the index of that element where it is to be written, like whatever you want to be printed. So this is how you use indexing for writing your specific element inside a list. Now list slicing. If you want to, like, just you don't want the whole list to be printed, you just want some part of it to be printed. For that you just write the list, the name of the list, then a box bracket, then a start, then colon, then end. You are going to just mark a start point. Like start point, what is start point? Start point is the uh, index number of the element that you want. Let's suppose you want it to be printed from banana to mango. So you are going to write here 1 and 3 because it is exclusive. So that it will print it 2. That is it. Like numbers here are written. Print numbers 1 is to 4. Like that. So I hope you got a little idea about it, like slicing and all. Now I will just uh, make another video for this all. Like it is going to get a little complex. Just in the next part, just get go through all these things like slicing and all, indexing and all. Just remember all of this. Just go through all of this once again, so that it will be easy for you all to learn like the rest of it. So in this video it is only going to be a short video for only telling you the basics of it and for giving you an idea of this.